Good morning, good afternoon, and good evening. Welcome to our webinar. We're really happy to have you. Thank you for attending, and we're excited to share with you the work that we've done on our project, which is a reference for water consumption during indigo dyeing. Can I have the next slide? So before we get into the actual content, there's credits that we want to give, and the credits are important to us. First of all, I want to start with Rashid. Rashid, who's here, who's a panelist. By the way, I may go backwards. We have two panelists. We have Rashid Iqbal, and we have Paolo Leidi. Maybe you both can introduce yourself right now, and then we'll get to the credits.
Hi, Andrew. Thank you so much for the introduction. And we are really honored to be part of this study. And I would like to say a few things because it goes back to 2022 when you and Emily first discussed this idea of having the industrial benchmarks. I remember back then, just about every mill was bragging about being more sustainable than the others. And in true sense, they were all doing right, including ourselves, but there were no references. And for the first time, when you discussed about really having benchmarks or references, and we're talking about real-time references from the industries. So the idea clicked and was a great idea, a great initiative. And I remember our lead friend Miguel, he was part of it in the beginning, and he really helped us in setting up the standards and the right parameters and how to evaluate and set the stage right and to give you the right accurate data. So the entire team from Andrew Olah to Emily, late Miguel, Zanira, and of course now Paolo, everybody has done a great job, and we are very honored to be part of this and be leading this study. Thank you.
Thank you.
Paolo.
Thank you, Andrew. Thanks a lot. Paolo, I'm taking care of the technical part in Transformers. I'm a denim expert since more than 35 years, and I've been following all the process through spinning and up to garments. And it was really exciting for me to be part of this team and taking care and checking and verifying all the data. And verify what the results that can be achieved in our industry, which is always blamed to be the most polluting in the world. But we have seen with the results that it's possible to have a better industry. So that's was nice and very interesting results in study, which are giving us some benchmark for the next.
Okay. So then the credits. Let's go to the credits. So when we started this project, first of all, it's a bunch of talk and blah blah blah, and we shared that idea with Rashid, and Rashid's company actually stepped up to the plate and gave us a financing portion for the report, and that confidence in us and that funding, which was really appreciated, got us going. The second stage was that we hired Zanuri Denizman to help us with the research and the original writing of the paper. We went to Paolo, but before Paolo, since the start of Transformers, we had one kind of intelligence director or one kind of technical expert, and that was Miguel Sanchez. And unfortunately, Miguel died, and Miguel's loss was enormous. But this entire paper was his idea from the very beginning, and then Paolo came in and has been the technical expert on it. And then we went to Alden Wicker, who's quite well, known to write this paper, and she loved the subject, and she did a great job writing it. And we don't have credits here, but it should be Sadia Rafiq did the graphic art. So let's move to the next page. Then for us to do any report, one of the things that's important is that you have industry collaboration and industry agreement. So we have the following mills that participated in dye companies and machinery companies. So first of all, Advanced Denim is in China and Vietnam. Blue Sign is in Switzerland. Candiani is in Italy. Crescent is in Pakistan. Diamond is in Pakistan. Dystar is in Germany and China. Karl Meyer, I don't even know all the places, but Italy and Germany for sure. Pakistan is Sorti. Orta is Turkey. NDL is Pakistan. And I can't read the last one. Can anyone else?
Morrison.
Morrison in the USA, one of the most famous denim dyeing companies on earth. So the reason I'm reading this to you is because this is a group of companies who compete. For instance, Morrison and Carl Meyer compete for every dye machine in the world, like Coke and Pepsi. And yet they sat down together and helped us with this, with creating a standard, or not a standard, but creating information. All these mills compete dead on, some of them from the same country. Yet here they were, week by week or by week, sitting down and discussing their results of their own dyeing. And this is what makes me proud to be in this industry. And people say all sorts of things about our industry. Thing that makes me proud, it makes me want to get up every day, is the mills and the machinery people collaborate. They want to do the right thing. Next slide. Well, I've gone through this. You guys know who's here. It's myself. I'm Andrew Olah. And why this study? Well, very simple. This study was done because of a lack of information. For those that don't know, I used to have a trade show called the Kingpin Show, and it was a show about the supply chain. And denim mills, I would walk around the show, and denim mill after denim mill were giving information about what their dye process was and how much water they saved, because that's a selling feature. But nobody knew if it was true or not. We still don't know if it's true or not. But we now know after this report what it probably is and how to figure it out. Next. Well, I'm going to ask Rashid to answer this question because as a mill, he has a fundamental decision to make when he buys a dyeing machine. One or the other. You're going to have a slasher or you're going to have a rope. What is it that makes you decide what to do? What are the
Very
choices?
interesting question, Andrew. And there is no one-word answer, or there is no right or wrong decision to this. There are a lot of factors to be considered while taking a decision. Uh, Rope versus slasher, which way to go. Now, both are producing amazing denims, beautiful shades, very sustainable processes, best practices, and everything is there, very intact. Technologically, both are very advanced in last few years. So here's the thing: if a mill is planning to produce 700 to 800,000 meters, and they want more versatility in their product, in terms of running different warps, running higher ends, then of course they should go with slasher. Now, having said that, rope has got its own advantages and disadvantages. When we talk about rope, we have to add extra process of ball warping, rebeaming, sizing. Just to compare the numbers, with one rope rope dyeing with 24 ropes to 36 ropes can give you around 2 million to 3 million meters a month, compared to a million meter with one slasher. So that itself is a huge difference in the output and the production. Number one. Number two, of course, the continuous dyeing gives you an advantage. There is less downtime, less changeovers, and especially when I talk about less changeovers, let's say if we are running a particular shade of pure indigo, and we have three different constructions or three different yarn counts, without really stopping the machine, we can continuously run the machine by tying the yarn to the ropes, and we get better efficiencies. We're talking about less material loss or no material loss. That itself is very huge in terms of sustainability. So there are advantages. If you're looking for a higher productivity, then of course, rope is the direction, and we opted for rope.
Okay, next slide.
So then thank you, Rashid. You explained very clearly the two technologies, which I would say are existing in the world, and depending on the country or in the area and the tradition, you can find places where mostly are slasher dyeing, like for example South America, or places like that we have mostly rope dye machine, like in Pakistan, for example, or in Turkey, or where it's common to have both the technology installed in the same mill, like in China, for example. So when we went to when we set up this study, we wanted to compare really the dyeing process, regardless the technology, regardless the place where the mills are, and without influencing anything in the process. I mean, we wanted the mills were running their own style their own method, with their own experience, everybody. Just what we said, we fixed the boundaries of this trial. So we set the assumptions and we said, okay, we have to compare apple to apple. So if we want to compare the consumptions, we have to start from the same starting point. So that's why we fix some conditions, which are basically to be dyed. What to be dyed means the yarn count, which is basically the same for everybody. You can see this chart is summarizing the assumptions and the results at the same time. And we said, okay, we want the trial are based on the average count 9. So all the mills, they used what they had running or what was in their normal production. So you can see from 9, 10, or 8.5, 8.8, basically are the same. The second point we fixed was the number of ends, because, number of ends means also the quantity of yarn that is produced, the quantity of yarn that passes through the machine. So it's also affecting the use of water. And we fixed the average 5,000 ends, which is a average number in the denim constructions. Of course, when we compare, because some mills have slashes, some mills have the rope, or both of them. So when we went for the slasher, we said, okay, it's 5,000 ends is the average you have to consider. And for those who were running the 24 ropes, so the rope dye machine, we said, okay, you have 2 sets running. So that means 10,000 ends. And again, all the mills are in the average of these values. The third point we want to fix was the pickup, the indigo pickup. Indigo pickup means how much indigo, how many grams of indigo we put on the yarn. And it's expressed in percentage. So when you say 4%, it means that we have 4 grams of pure indigo per 100 grams of yarn, which is processed in the machine. And this is the another fixed point we gave. So 4%. But we said, we of course, we didn't want anybody to change the recipe. But we say, okay, in your range of colors, choose the one that is close to 4%. So we have 4, 4.5, 4.4, 3.7. So more or less we are in that area. The last, then comes what is belonging to each mill. For example, the speed of the machine. You see that in the chart, we have different speed. We assume the average speed of 25 meters, which is average, but each mill has their own habits. They have their own way to run the process. So we have from 27 to 30, 25, 20, like that. The weight of the yarn is just a matter of calculation, how many ends and the yarn count. So and the same, the warp feeding in the dye machine depends on the weight of the yarn and the speed of the machine. The other thing that is different mill to mill is the number of dips or number of indigo boxes. That means how many times the yarn goes into the dye bath and how many times it goes into the oxidation section. Again, in this case, we didn't want to influence the mills. Everybody chose their own way to achieve that indigo pickup. So somebody was using 7 boxes, 7 dips, up to 10 dips, or even 12 dips. We didn't influence this because, I mean, this is the way each mill is used to produce. Given a certain standard fabric, each mill was free to choose their way to process the yarn. And then there is we concentrate on the water used in the last washing boxes, I mean the post-dyeing washings. We didn't consider the water used in the pre-dyeing process. Why? Because this is more or less similar in all the mills, and it's not that much important in our study. Of course, it's important as a consumption of water, but it's not that important for our purposes, where we want to see the results of the dyeing and the effect of the water on the dyeing. And it's quite interesting to see how different are the results. We were assuming to have something like 10, 12 liters per kilo, but in the results, which are numbers given by the mills, and of course, they don't want to give us wrong number or bad numbers. Everybody trying to give good numbers. And we have the results that are ranging from 13 to 15 liters per kilo of processed yarn in the rope dyeing, and from 7 to 10 liters in the slasher, 7 to 12 liters in the slasher. Of course, this data have been verified. We had external people, external auditors from Morrison and Carmila, who went to the mills and they checked with flow meters, with liter counters, and everything. They provide an accurate report, testing and checking and assuring the numbers were correct. Again, without influencing anything in the mill. The mill was the only one responsible to decide the process, how to run the process. As a further check, we want to analyze how much indigo was wasted in the process, because this is another good point. You can put a lot of indigo on the yarn, but then if in the washing you waste everything because it's not fixed and it's washed down, this is another big point to be analyzed. So you can see in the column in the indigo waste in washing, this is the concentration of indigo that we found in the water, in the washing water, so gram per liter in the water that was discharged in the last boxes. So gram per liter means, for example, 1 gram per liter means the water from the washing had the content of 1 gram per liter of indigo. Of course, we did not investigate the concentration of indigo in the dye bath, because this is something like, say, secret for each mill. Recipes are something secret and depending from many factors, so we did not investigate. But the indigo in the wash water and the wastewater was there. Coming from this washing, the content of indigo in the washing water came what we call efficiency, the dyeing efficiency, which is not efficiency in terms of productivity, but the efficiency of the color we put on the yarn. If I put 4% of feed this quantity of indigo in my machine, in my dyeing section, how much is really in the yarn and how much is wasted in the water? So you can see that numbers are ranging from the 83% to up to even 97%. That means some processes are run in the best way, in the better way, in order to have a higher percentage of indigo fixed on the yarn. And some other cases, the results are lower. Of course, there are many parameters, many reasons that may affect these results, which is not now. The target of our study was not to investigate the efficiency, but we thought it was important to show also this value as a result of our study. So at the end, we say on the next slide, please.
Before we go to the slide, can I just interrupt for a second?
Yeah.
For anyone that has a question, if you could put the question in the chat, we'll answer it. Thank you. Sorry, Paolo.
Okay. Yeah. So if we want to take a final result of this investigation, let's say the average of these mills, by the way, these are all top mills. Mills that are selling their denims worldwide at the highest levels. So we're not taking unknown mills. All of them are well known. Of course, we don't show the names because it's a method of just comparing results. And we found that in the consumption, which is generally ranging from 13 to 15 in the rope or 7 to 12 in the slashing, can be actually reduced. There are mills that are using much lower quantity of water, like a 385, let's say between 3.5 to 4 liters per kilo. And machines are basically the same. No process was using extra chemicals. No process was using strange dyes or additives or fixing agents. We concentrate on pure indigo dyeing and no other post-dyeing processes. So that, like, for example, to fix the indigo and reduce the bleeding, so reduce the quantity of water. Everybody was on the same level. The results here give us the input that is possible to drive the managing or the handling of a production in a better way. There is the way. It's only to be probably a bit more scientific in the approach of the process. So we would use, I mean, when I started in 1987, I was used to have this number in my mind. 10 liter per kilo is a standard consumption of water in the Indigo dyeing, but it was 38 years ago. Now, nobody was trying anything, nobody was testing anything. In all this period, we assume that some evolution had been in the technology, and also the knowledge of the process has improved a lot. So approaching the process in a more technical, more scientific way, we can be sure that what exactly is needed to get a good result. Not just because we were used to make like this since ever, we have to continue the same way. So that's what is been shown by these companies that are using so much less water in the same process.
We have a question, and I'm going to actually give it to you, Paolo.
Okay.
One of our viewers asked, what did the NE mean in the column warp yarn?
Oh, well, the NE is a conventional number. It's a English number. NE stands for English number, and actually comes from the number of hanks in 1 pound in the weight. It's an old system to measure the thickness of the yarn. And in the English number system, higher is the number, thinner is the yarn. So if I say, for example, NE8, which is the yarn normally used for coarser counts for heavier fabrics. Let's say the heavier fabrics goes from NE7 to NE8, 8.5. That count, that yarn is much thicker than, for example, NE20, which is a typical yarn used for chambray or for lightweights. So it's a conventional number which gives us the measure of the thickness of the yarn.
And we asked all the mills to try to use the same number, but everybody has a different production and a different way. But we tried to standardize that.
Yeah,
Oh,
I mean, this count 9 is very popular in the denim production.
yeah,
So
and
as you see,
there's no way to. I've just been asked, Paolo, if we can change it to an American measurement, but there is no American measurement in denim.
no, no,
In
there is
textile,
only two ways.
yeah,
A textile is an E, or you can use the metric number, which is the English number divided by 0.59. But the
that's way
metric
more
number
complicated.
is not that popular.
Way complicated. Okay, let's go to the next slide. Well, the implications for stakeholders, I think it's pretty obvious. Brands, now when the brands are told something about their supplier on how much water that they use, they have a methodology to ask the supplier to convert to or to talk to about, or they can come to us. We have, as a nonprofit organization, we're happy to go through their process and to confirm that they're really doing what they say they're doing. Mills, which I think is brilliant, now have a chance to openly see other mills' behavior and can follow the best practices. And that's a tenet of Transformers. We want to support the best in technologies, and the best technologies are meant for others to match or even to improve and to show that they're even better. So it's great for the mills and policymakers. Well, we could just have a big wish that policymakers would get inside the products and understand best practices. Next slide.
Oh, well, I can say something about this. Um, this report, this study, we focused on the water in the post-dyeing treatment. But of course, this is just a small part of the entire process in the denim production, which is involving chemicals and the water. The water, water managing. It's a big issue in the denim industry, and the use of water, of course, is connected to the wastewater treatment. Now, the mills that we involved in this study are located in different countries, from Italy to Pakistan, China, etc. And of course, each country may have different regulation for their wastewater treatment. If I can say, Italy, when you discharge water, this water must be nearly drinkable. In other countries, maybe there are other rules. It's also connected how is the system working, if the mills are in some industrial park with centralized system, like treatment, etc. But we thought that could be interesting in the future to investigate, first of all, to compare what are the limits mill have to consider in their wastewater, depending on the country, and to see if there is any alignment. Because mills that have to treat their water up to a certain limit compared with another one, they may face different costs and different challenges. So this is one thing we want to in the future we want to investigate. The second is how the wastewater treatment can affect the waste of water. I mean, already we have mills that are treating the water and recycling into the process. This is something happening. But beside this, there are things that can be like further steps. What happens if we can reuse the water directly without treatment? Maybe some water coming from some machines, which is already can be done, can be recycled without any treatment. I mean, at the end of the story, we have to consider the global cycle of water in the industry, in our denim industry, and what is the best way to use the water as a resource. Of course, we cannot reuse the water that we are exhausting the drying sections, but that's a part that is the same for everybody. So that's what we want to focus in the future. And this goes also together with the indigo recycling. Again, when I started 30 years ago, I was working with a mill in Switzerland, which was used as a normal practice to with membrane ultrafiltration to recover the indigo from the wasted water. Recycle the indigo, recover the indigo, and reuse it in the normal dyeing process. Then it was stopped because of cost reasons, energy cost. At that time, this membrane was extremely expensive, and the indigo price was decreasing sharply. But now the situation is changing again. Now we have to see to this problem like a sustainability problem. So if I can recover the indigo, I get from one side, I can reuse the dyes. From the other side, I reduce the need of treatment of my water. So this is something again that we want to investigate how many mills are sensitive to this problem, how the problem can be faced, if there is any special innovation in this direction. Leaving the dyeing section, yeah, please, sir.
I have two questions, Paolo. Sorry to interrupt. The first one is, has the University of Georgia's process been evaluated by transformers? It was recognized, and I don't know if either of you, Rashid or Paolo, have heard of this, it's been evaluated by transformers. It was recognized by Fashion for Good in 2022. In concept, it has the lowest water consumption that all the stats listed in your table. I don't think we've recognized it. I don't think we know what it is. Do either of you guys know what it is?
I have no idea what's the University of Georgia process.
For the person asking the question, I think it's David. If you can give us information, we're happy to look at it. The second question is, did you also benchmark the whole process of indigo dyeing from pre-treatment dyeing, post-treatment in terms of water and energy?
Yeah, as I said before, we just focusing on the last section of the machine. Now, the dyeing machine is composed by a pre-treatment section, a dyeing section, and a post-dyeing washing section. So we focused only on the last one, and the reason is there is the biggest quantity of water comes from there. So that's why we focus on that one. And also because it was easier to check that quantity isolated and to isolate and measure that quantity. The pre-treatment, again, we should have given a very strict process to the mill. I mean, because there are so many different processes in the beginning, and depending from many factors.
Okay, next slide, if there is one.
There was something in the previous one, if you want to add on the previous one.
Previous slide.
Yeah. Okay. I mean, just very quickly, finishing process. I mean, it's the same like a dyeing. I mean, the use of water and the wasting of water in the finishing process is the same like in the dyeing. So it's another big area because most of the time we just focus the dyeing because it's dirty, but finishing as well, it's a very important area we are thinking to investigate in the future. That's finished.
Great. So, Andrew, just to jump in, we have questions coming through on the chat, which you read, but we also have questions coming in on the Q&A. People are welcome to use either, but can you see the Q&A or do you want me to read it out?
I can't see anything, actually.
Okay, great.
I haven't seen a thing on my screen.
We have a question from Claire, which says, what surprised you most and what action would you like to see?
Rashid?
What was the question again? I couldn't follow, please. Can you
So
repeat?
what surprised you most, I'm guessing, about the study, and what action would you like to see?
Well, there were no surprises, to be honest with you. It was a great initiative in the right direction, and I hope we do more research, more study on the next processes. The surprising part, yes, was when I was to when the data was shared for the first time. Since we are running a rope dyeing, so we wanted to compare the numbers without naming the mills. There was quite a big difference in the water consumption. Now, that doesn't mean that one is better than the other. Of course, there are many factors involved, the region, the country, the environment, the temperature. But what my take was that, if we want to correct and learn something, then this is a great tool, how we can improve our water consumption. So that's one of the things from this. That's the lesson learned.
Okay, great. I'll read one more unless anyone else wanted to jump in. The next question is, has anyone any recommendations given to mills for improvement?
Well, it's not about, again, numbering the mills one over the other. The idea was to share the real-time data. And that was the first step. And it's up to the mills now. Like I said, we have the data in front of us. And if somebody is doing achieving a better water consumption, that is something to learn and improvise on whatever we have done so far. So that's a great tool again. Yeah.
And share. So the point here is not that somebody's so much better than somebody else, but the point is that we have a system for the industry to compare those that perform well versus those that don't perform well, and to prove it. We didn't have that before. Let me put it another way. You have a company X, and company X goes to their customer, American Eagle, and says, "Oh, we have a 70% water saving." And they don't tell you how. They tell you a marketing how, but they don't tell you really. And then you have another company, company Z, and that company's actually doing the right thing. And those two now can share the way they do it openly, and you can prove that one is better than the other. So this is meant for the non-efficient companies can't hide behind no data. This is really what it was for. The good companies that perform really, really well and do a really good job in environmental behavior in manufacturing, they don't want companies that don't to say that they do. This is greenwashing at the highest level. So what we wanted to do is to stop that.
The difference is talking about in percentages, talking in absolute values. You can reduce by 90% your water, but you're using a river water, you reduce by 90%, you still are using a lot of water. So
Yeah.
you're using a normal quantity and you reduce by 10%, you're using 10% less of water, so you really reduce your quantity. So percentages are very tricky. It's a very tricky number.
Exactly.
That's why we want to go for absolute numbers, for real numbers.
Any more questions, Brahman?
Andrew, I have a question for you. Now, having said the differences in the water consumption, specifically on the rope dyeing, again, we have seen a huge difference between a mill, having a very low consumption to a little bit higher consumptions. Now, can brands use this as a reference as minimum and maximum, and then evaluate the mills and ask the mills to give the real-time data on the post-dyeing. Will that be considered?
You're asking that to whom?
To you, Andrew, for the brands?
Well, it depends. If brands are genuinely interested in sustainability or they're interested in marketing sustainability, that's a difference.
Well, I feel most brands should receive this research very positively. It's a reference. It's a real-time data, and all the mills globally, 7 mills have shared their data openly. So
Hope
they
so.
should.
We hope so.
Yeah.
We hope so.
Cool. That is all of the questions that have come through so far. People can continue to put them in the chat or the Q&A. I also put a slide, which I can flip to, of just some questions that came in on email before the webinar, but it's up to you guys.
We have time, another 10 minutes of questions if you want. We're
Okay,
good.
great.
I can answer the first question for sure. I mean, we didn't consider at all compromising on quality, on dyeing quality. I mean, as I said before, the meals are all top meals, and the results was, I mean, the dyeing process was their standard dyeing process. So absolutely nobody wants to compromise on dyeing quality. By the way, there was also checked some results in yarn crocking, which is something a bit difficult to do, but results have been not shown because very similar all of them. So if we start saying that reducing the quantity of water means compromising on quality, then there is no sense. Then there is no sense. Absolutely. I mean, the reduction of water has to come through a scientific approach to the process, to how to handle the process. What are the real necessity of water? Maybe I'm sure we always overestimate the quantity of water just to be sure. Nobody was taking care of this in the real way.
Okay.
What's happening?
Second question, what are the remaining challenges collecting data on Indigo? Who wants to take that one? I'll take the third one.
Well, I think the important in this case is what we measure the quantity of indigo that is wasted in the washing water, because it's again something that is underestimated in most of the mills. This is indigo that you throw away, so of course it's money because, but it's also polluting the water. So we are really, in the end of our report, we are pushing MES, suggesting the mills to take more seriously the analysis of their process and the quality of the water they discharge. Any data you weren't able to capture? Well, as we said before, we didn't analyze the consumption of water in the pre-treatment, I mean, before the dyeing. So we didn't measure any of those data. In general, I'd say in my career, I have visited so many mills in the world, and not so many mills are equipped with suitable technical instruments on their machine to measure the quantity of water. There are simple instruments are available. I mean, the flow meters or liter counters, very simple and very cheap instruments. Even mechanical. Okay, the most modern machines have everything is electronically controlled. It's connected to a centralized computer, so you can know in any moment how many liters are flowing in the machine. But there are still a lot of mills in the world that are really leaving to the operator how much to open the valve or close the valve, just with based on the feeling of the operator. This is something that should not happen.
Regarding the third one, was there more, Paolo? Is that it?
Well, in my opinion, there should be a regulation to force the people, but regulation should be based not only on scarcity, but on the feeling that water is essential for life. And it's a must to save water if we want to save the planet. So,
But
okay, the regulation is
I
a
want
thing.
to, I want to interrupt you here. So if anyone goes online to the, I think it's the World Bank's stats, which are fresh water per capita in the world, you will see that the places that we make denim have serious water shortages. So, for instance, Canada has 80,000 liters per person. United States has 8,000 liters. I'm just guessing in the numbers. They're roughly like that. And then you come to Pakistan, it has 400. Egypt, 0. Pakistan or India, very, very low. Bangladesh, the worst. So you're talking about the places where we're making denim as having no water at all, basically. I mean, compared to Canada, 80,000. In Pakistan, 300, 400, 500. Turkey, 2,000. It's tiny numbers. So we have a really big, Paolo's right, sorry to interrupt, but regulation is a big deal. But actually, practically speaking, the denim industry is going to use up all their water.
That's why scamming is so important, the recycling and the clever use of the water.
Okay, I have another question here. If I can read it. Rope dyeing is 3.85 liters per kilo. Can that be an amazing benchmark? But we need to know more, as there are more processes in the market, which post-treatment are based on different fixers, binders, and reduced water usage. Rashid?
I think the study was only on the post dyeing, and there were no fixes used in the process.
Okay.
That was the standard set by Miguel. And in the beginning, the only challenge was how to make sure that we have one standardized process across the board. So that's what it is.
All right. The next one is, in future studies, can you also consider the energy parameter? I'll answer that. Yes. And in future studies, we also want to study, I think is really important, is wastewater, because there's all sorts of, every country has a different standard of how the mill returns what's supposed to be clean water. So California is different than Bangladesh, and Bangladesh is different than Egypt. So we have to get into that and compare that as well. The next question, the report primarily focuses on data collected from denim manufacturers in Bangladesh, India, Pakistan. Were there other regions excluded from the data with specific reason? No, there's no reason. It just is the way it is. We thought we had a fair representation. And we have the dye machines, which is what everybody uses all over the world anyway, and they were involved. So Morrison is supplies. I don't know the numbers, but between Morrison and Carl Meyer, they supply a really big percentage of the machinery or copies of their machines are all over the place. Any other questions?
We have one more in the Q&A, which is foam dye entirely replaces the traditional water vats and chemical baths of conventional indigo dyeing. Isn't this so?
Well, that's an interesting question. I think the foam dyeing, from what I know, is not active in any scale anywhere. So there was a lot of talk about it, but when it was time to actually produce, the volumes were not what anyone thought, and it's not really efficient, or I don't even know the details. But I do know that the uptake on it in production is minor.
Very, 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 very limited. It's very, very limited. There is only one or two machines supposed to run with the real foam dyeing. But I mean, it's not something that is going to substitute the normal dyeing process. Absolutely.
Well,
Absolutely.
we hope it does, but they need to bring the technology.
Yeah, from a practical point of view, as it is today, I don't see any chance for the foam dyeing like it is today to take the place of the regular dyeing. I think the big question for everybody now is to first step is to optimize the processes we have today. That's the first step that everybody can take easily and without changing too much or investing too much in a machine. But optimization can be done easily.
Another question is, will Transformers Foundation conduct this research and report annually? We do annual reports, not necessarily on Indigo. The Indigo one was with the Indigo Council was a special one. I don't know. We haven't discussed that. We could possibly do that. If we have support, we need support as well. But hopefully we can do that. Is that it,
That's
Bronwyn?
for the questions. Yeah. Yeah.
Well, you guys have been a fantastic audience. Thank you for coming. Thank you to Paolo. Thank you. You guys want comments before we go?
It was a pleasure
Thanks
to
a lot.
join this webinar.
Likewise, it was an honor and a pleasure working alongside the industry experts and professionals. And this is the first step in the right direction, and we hope to see more of these research conducted over the time. Thank you.